Well, hello friends, nice to see you again. Hopefully you're finding some of these videos useful. Hopefully you're still trying, haven't given up all hope. Finish strong, we're almost there. But this is classwork 11.3, page 767, numbers 1 through 19 odd. I'm going to be demonstrating just 3 problems here because there's 3 basic skills on this classwork, and that is sector area, segment area, and arc length. Which I'm actually not even going to show the arc length. Maybe I'll throw that in really quick because I realized I left that off. But I tried to pick what I thought were the 3 most difficult problems because that's what I try to do on these classwork videos. So let's go ahead and get started and see what we can do. Number 5, I want to do number 5 because it's a scary word problem. Number 3 is same as number 3. It's a sector area problem, but we just have to visualize what's going on with the description. So it says the beam from a lighthouse is visible for a distance of 3 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? Okay, so again, it's a chapter on sector area, so it must be creating some type of a circle. So here's our lighthouse, and it's going back and forth. It's sweeping. It's trying to alert everybody, watch out, don't crash into the rocks. And it says it's sweeping back and forth at an arc of 150 degrees. So it's not spinning in circles. It's trends. It's like a sprinkler going back and forth. So 150 degrees is our angle here, because you can imagine this is part of a larger circle. It goes all the way around like this. Okay, and then it says it goes out for 3 miles. So that means the light can penetrate at a distance of 3 miles. Well, that's just our radius. So we've got 3 miles, 3 miles. So there we can take the word problem, and so it says find the area covered by the beam. So we're just finding this piece of the circle. It's just a sector area problem, okay, just like number 3. So if you remember, what we do is we take the partial degrees over the total degrees, which is always 360, times the total area, which would be pi r squared. If I wanted to know the total area, say this thing was spinning, I would just do pi r squared, but I only want to know a partial piece of it, 150 degrees out of 360, then I can multiply it by this fraction. So we'll be done in just a few seconds because we're going to plug in our degrees, which is 150 over 360. We're going to multiply by pi, and then the radius 3 squared. I'll do it like that. Okay, which again you can see is just going to be 150 over 360 times 9 pi. All right, well, let's do it. Sorry, I can't talk more about it and make it more complicated. Let's see, so 9 pi times 150 divided by 360. So we get 11.7. It says to round to the nearest mile. So I'm going to round that to the nearest whole number, 12. So we have here, it covers an area of 12 miles. There it is. It's approximately 12 miles squared. Nothing much more to say. Again, fractional part of the degrees times the total area. So so 12 miles is 150 degrees out of 360 of the total area of this circle. Okay, well, let's move on. Let's go ahead and do number 7. Number 7 is a little bit more complicated because it's the segment area problem. So we don't want to know the whole area of the pizza. This would be like finding the whole pizza slice. We're going to want to know the area of the crust. Okay, so that's just going to be sector area minus triangle area. We use our trig triangle formula. Okay, and that will give us the segment area. Okay, so I'm actually going to use this to fill it in for all 3. So my sector area, if you remember, is the measurement of your angle over 360 times pi r squared. I'm going to put the formulas first. Okay, so in this case, that degrees we're looking at are just 60. So 60 over 360 times pi, and the radius is 20 for number 7. So 20 squared. Okay, I'm not going to do anything fancy. I'm going to put that into my calculator and crunch those numbers. I could simplify it, but let's see. 20. Oops, let me do this right. Careful of calculator error. 20 squared is 400 times pi, that wonderful number, times, now let's get the fractional piece, because that would be the total area of the circle, but I only want 60 out of 360. And there we have it, 209.4. So if this was a sector area problem, I would be done. That's 209.4. So that's the entire piece. So now we need to know the triangle area because we need to remove that piece. Formula for that is 1/2 AB sine C. Okay, and the reason I'm having you learn this is because all of those numbers are immediately available. We don't have to do any extra work to find the base because, and again, it would get a lot more complicated having to find the base and the height. I think this is a lot easier if you're just willing to learn a new formula because now I just go, okay, well, 1/2 times my two sides. Here's my triangle. My two sides are 20, and because it's a radius, I know my other side is 20. So it's just 20 times 20 times the sine of the angle in between them, which is 60. So there we go. It's going to be, I'll go ahead and simplify this one. Well, yeah, why not? 20 times 20 is 400. Half of that is 200. So this is going to be 200 times sine 60. That's just a little easier and safer. Sometimes it's better not to put too much in your calculator because you can, like I said, operator error, especially these touch pad ones. Sine 200 times sine 60. 173.2, which again, it's a big number, but it's less than 209, so I must be on the right track. 173.2. So that is this area right here. So now I just need to subtract these two numbers, and I will get my segment area. Okay? So 209, oops, 209, see, that's what I don't like about these. 209.4 minus 173.2. And we get 36.2. Okay? Bingo. 36.2. And that is how much pizza crust you're going to throw away if you have not been taught and disciplined to eat your pizza crust. Or if that's the best part, if this is stuffed crust with cheese. Oh, stuffed crust pizza, praise God. Okay, so 36.2 meters squared. So again, a little more work, but again, you do this enough, you'll get very good at it. You can see, you just plug and play. You find the whole sector area, find the triangle area using this beautiful trig formula. You'll really impress Mr. A next year knowing that already. And then you just subtract those two. This number should always be pretty close to this number because, again, the pizza crust does not make up much of the overall sector. Okay, let's go ahead and do 15. Again, just doing it for you because it's it's an area. It's a word problem, and word problems sometimes intimidate us. But let's take a look at it. A lunette is a semicircular window that is sometimes placed above a doorway or above a rectangular window. To the nearest square inch, what is the area of the lunette? So we are trying to find area. So immediately we see this is actually like the lighthouse problem. This is like number 3. It's sector area. So that means we have a partial degrees over 360 times the overall area of this circle, as if the lunette went in a full circle instead of just being half. And so that's really key to start filling this in. We can see that it's half of the window, or it's half of a circle. So you can either realize, okay, so how many degrees is half of a circle? And I could write this as 180 out of 360, because that is 180 degrees is half of a circle. You could also immediately make this 1/2, because all we're going to do is find the area of the whole circle and cut it in half. So keep in mind that's what we are doing, whether you want to enter in your calculator here like this, or if you just want to find the area and cut it in half to solve. So 180 out of 360 is the fractional piece we're looking for. They don't give you that degrees because that's what you have to realize that. Oh, this thing is obviously just half of a circle. But the radius, pi times the radius, be careful with the radius. They give you the 40 inches all the way across. That, of course, is the diameter, not the radius. So how do you find the radius? That's right, cut it in half. So we're just going to do 20 squared. Gosh, we've squared 20 a couple times on here. So 20 squared is 400 pi. So we've got 400, that's a lot of pi. 400 pi times 180 over 360. And again, I'll show you, plug that in, or this is just 1/2. So what's half of 400 pi? That is simply 200 pi. And so if I didn't have to find a decimal answer, that's my answer. Or I can go ahead and do that. 200 pi equals 628. And the nearest full inch, so we're going to drop all the decimals. So that's 628 square inches. 628 inches squared. Again, not too shabby, not too difficult. Let's see, I did not do a arc length problem, and I don't know if that's troubling for anybody, but let's go ahead and try one. Let's go ahead and do, I'm going to, bonus problem here. You can turn off the video if you don't want any help, but I'm going to do number 9 really quick. I'm just going to squeeze it in here. Number 9 is find the arc length. And so that's going to be just like sector area, except instead of using the area formula, because we're not finding a partial piece of area, we're just finding a partial piece of the circumference. So when we're doing arc length, just remember it's the measurement of the angle, partial piece, times circumference, pi d. It's an even simpler formula than area. I mean, they're both pretty simple. So if I look at number 9, they have given us a 45-degree arc. So that's 45, out of 360 times pi times the diameter. Now they've given us here's where you could make a mistake. They give it on the picture on number 9. I didn't take time to draw it. It's 16. So my diameter is twice as big as 16. So that means I want to put a 32 here. Okay, so 32 is my diameter. Pi times d is my overall circumference, but I'm only finding a fractional piece, 45 out of 360 of that entire bit. And so let's just plug and play. You guys are so happy we got these calculators going. Distance learning. It's a good tool. Okay, so 32 times pi. So that's my circumference. The circle is 100.5 all the way around, but I only need a fractional piece, a pretty small fractional piece, only 45 out of the 360 degrees. And so that gives me 12.57. They want it to the nearest hundredth, so 12.57 is my arc length. Again, very easy. And then it is in feet, no naked numbers, please. And it's not area, so it's not squared. So 12.57. So there you go, bonus problem, number 9, hallelujah. Just like what we did here, just like what we did here, just like what we did here, only because it's arc length and not area, we use pi d because we're finding a fractional piece of the circumference, not the overall area. Okay, tear it up. I know you're going to do a great job. Again, don't give up. Do your very best. And summer is here to save you soon. Jesus, more than that even. Go Jesus.